take it away.
Hi, all. Thank you. Thank you very much for being here. I'll give a little caveat for those. I guess we got oh, wow, lots of chats. Thank you for using the chat window. I have a confession to make. This is my first presentation. I just got back last night from being in the woods of Maine, and I spent far more time thinking about chainsaws and ruts and dirt roads than I did about generative AI. So this is not, you're going to get the fresh take on it. It also does mean more practically. I was a slide or two at the end. I was hoping to write it this morning. I didn't. So I'm going to improvise a bit, and we're just going to do what I would have done that slide. And we're going to walk through it using a couple of examples. And I may call on some people in the audience for that. So with that, my understanding is that earlier this week, or there were a couple of presentations. I think Saxon kind of gave a really good overview of some of the AI technologies. So I'm not going to dive deep into that. And then I think several people from Greenhouse, Office of the CTO, across the company kind of talked about projects they were doing. And those are all great things. And those are great examples. One of the, I get distracted by chat, that's my problem. One of the things, so what I wanted to accomplish here is to help people who are in the product, well, anybody across F5, but especially people in the product team. That's close to my heart. That's what I did for 5 or 6 years when I first joined F5, about how do we think about AI, incorporating AI into the products and services for F5. And this is not meant to be a super technical talk. This is more about meant to be, how do you approach the problem? How should I think about the problem? I'm not super techie. I haven't fired off my own LLM like some of the engineers have. How should I think about this? So with that, let's see, am I screen sharing? I am not. Do that. All right. So with that, first key point is AI gets a lot of hype, and I want to just level set everybody in terms of AI as a tool, just like any other tool in the product building toolkit. Now, it's a very powerful tool. It's a tool sort of like cloud computing, or if you want to go back further, like an engine, right? It's often compared to gas, when the steam engine or gas engine was put in there. It can do lots of things. When you have a very powerful tool, it's very tempting to use it like a hammer, right? That old saying of, if your only tool is a hammer, everything looks like a nail. And that's a little dangerous, right? Because not everything is a nail, and then you force fit things into a solution they're not ideal for it. So my goal today is then to help you understand AI as a tool in your toolkit. Like any tool, it's good at some things. In fact, it's good at many things. So what is it good at? What is it not so good at? Because that's also important. Say, hey, maybe there's a better tool for this. And then the things that I think about, and I hope will help you think about, whether or not to use AI, and maybe if you do choose to use AI, what sort of AI? AI is a very broad and expansive term. Lately we think about large language models and generative AI, but AI does, I think Saxon talked about this, there's classification, there's expert systems, there's rule-based stuff. So there's a lot of AI, and the evolution or the advent of these large language models does not replace or supersede those other things. Those other things are still very good and have a role to play. In fact, for many things about what F5 does in F5's business, some of those other tools are better fit than generative. Generative is good for some things, but not everything. And Fade, I'll ask you to just keep an eye on the chat. If there's anything, any questions, pop them up. Just let me know. I'll pause at the end of every slide. I'll take quick questions quickly, and longer questions, I'll probably, to be transparent, I'll defer them a bit. Mudit, the Greenhouse team has heard me say this many times, but it's where we should start as engineers, as product managers, as people who want to solve problems. It is to start with, what is the problem I need to solve? Not how should I use AI to solve something. It is, what's the problem to be solved? And the problem to be solved doesn't start with the technology being used. The problem to be solved starts with a customer a statement of the problem and why it is a problem. And so I use this framework personally. It's very much like how an agile story is written in the agile mind and the agile framework. It is who needs to be able to do what and why. So each of those three things has, each of those three things, who, what, why, those three W's, has an important role to play. So who, right? That's the lens to view the value proposition from. We'll get to that, I think, on my next slide. But when you have value proposition, the value proposition going to an expert user engineer may be very different than the value proposition going to somebody who is just a small business owner. So you have to look at the solution to the problem through the lens of the customer. Second, the what is how we grade our success criteria, right? I need to be able to do this thing. We go off, we design something. It's always good to then say, did I meet this? This is requirements. What are the requirements? The why is when you go back and say, did I really solve that problem? Was there a better way? I might have hit all the success criteria, but when I put together, I go, wait a second, that's not really solving the why. Or sometimes you realize that I did all this, but now that I've done it, I realize that the why, the reason that this is a problem, can be better solved just doing some other way, but the different set of requirements. So that's why it's important. The starts with why framework that I think you've heard Kara use in some of the things is exactly about this. I know this is less to do with AI, but more to think about the problem. But it's a way that I use to say, don't start with the technology, start with the problem. So one framework, not the only framework, but I think this is a useful one. It's one that's easy to remember. All right, I had the three W's in the last one. Now I have the three E's. What is the AI value proposition? Number one, AI can make something easy, right? You see this in the use of generative AI, right? Where I want to learn about a subject and it makes it very easy to do. I just type in a natural language English query and it comes up with an answer. It is taking what you could do, maybe using other set of tools, often a complicated, complex workflow, and make it a lot more usable. This matters, right, from business sense. Now, again, that's the value proposition, but the business value is now I can expand the set of customers who can benefit from this solution. In applying this to F5, right, we hear at Francois Strategy Day, I heard that Francois talked about, all the execs talked about making things ridiculously easy as a focus for this next year and going forward beyond the year. I mean, there's so much I want to say here, but we have a lot of powerful features. From F5's perspective, making them easy to use is where our biggest challenges are. That's where our competitors, I'm closest to the security space. And if you look at our security customers, you look at companies that get a lot of hype, like Cloudflare. They take something that may not be as good as ours, but they make it very easy to use. So easy is something AI can definitely do. And we talk about some of the technologies, we'll talk about how that works, but easy is definitely one of those things. The second thing AI can do is it can make a customer more efficient. In other words, you hear about faster, better. This is the faster part of faster, better. In other words, I can take something that may have taken maybe an expert user, I don't know, a day to do. Maybe it's a forensic analysis of a security breach. And I can reduce that time dramatically. I'm not just 10, 20%, but you can reduce it by an order of magnitude, by 10x. You can take what is a day's work and reduce it to an hour or less by using AI. AI is very good at, for example, finding those needles in the haystack. And so this is the second value proposition, right? And the value is that it reduces the cost. So direct benefits the customer. Hey, it becomes less expensive to have a high efficacy security solution. It also, because it is so much more efficient and the cost has gone down, we open up new use cases where it was just simply not cost effective before, and it is now. And then Third, it can make us more efficacious. Now, this is, by efficacious, first I define it. This is the quality of the solution. This is, in other words, by leveraging AI, I can, and I'll put it in the security context again, because that's the one that I'm most familiar with, the one I naturally gravitate to. I can find threats, I can find bots, I can find fraud that nobody else can find, because I can leverage AI to just find things that nobody else can solve. The soapbox I was going to get on a moment ago was, this is what is historically been in F5's DNA, and it's what some of us naturally gravitate to say, hey, how can I use AI to get an even better solution? And I certainly don't want to throw water on that. I don't want to discount that. But I do want to say that remember, easy is where we need to mostly focus. We're going to open up more markets by making these things that are as efficient and as efficacious as they are already within the F5 portfolio, and making them easy to use. That said, if we can make things more efficacious, absolutely. And that's the comment in red here, is anybody in F5 can leverage AI for all of the above, but easy is the one that has the best alignment with our strategic direction. As a little side note, I was chatting with Cara, just actually, that was my first chat back, to when I was getting back from Maine. And I told her I was going to be giving this little presentation. I asked her, is there anything you want me to hit or emphasize? And she said, even before she saw the slides, which were only made a day, before I even gave her these three, she says, emphasize the ridiculously easy part. So again, easy is one of those things that we need to focus on. And from a matter of just, if you've got a greenhouse project you want to work on, that, something that really makes things easy are going to be more attractive to the board to look at, to say, hey, we want to fund that and push on that than the others. With any questions, any comments or questions that came in?
We're going to take them at the end, Ken.
Okay, great. So now, great. What are the problems we want to solve? There's three sets of problems. I break into three sets of problems, at least when people are coming to me and talking about ideas. Is this an internal process that we want to make more efficient? Right? Examples of these, not an exhaustive list, right? Is like, F5 procurement. What do we do in tech services for support? Automated workflows. Can we make them more efficient or more easy? And those definitely help F5's bottom line. Since the title of this presentation was for products and service teams, that's not where I'm going to focus, but it is an important thing to not ignore. If you got an idea and you say, well, it's not one of these, it still could be really useful. Second is take a customer-facing process and make it more efficient. And I think a couple of the presentations you saw on the last, a couple of days ago, were about this. They were things like creating vulnerability disclosures automatically, or finding related bugs. These are things that are customer-facing. Customers see our bugs, they see our SBOMs, they see the iRules that are created, they see the knowledge base articles that are on Dev Central. If we can make that more efficient, more easy, that adds value, right? One of the projects I find most interesting in Greenhouse is a project that mines the Dev Central and knowledge base articles, builds a corpus of specific to that data set, and then you can ask it questions like you do for ChatGPT, and it answers those questions. I believe, and I think we have some legal people on the call, that's one of the things that we are allowed, that is an allowed way to use data. If so, please interrupt me on chat or something and correct me if I'm wrong. But that's really exciting because it doesn't involve any proprietary customer data. It's all public data that F5's put out there. It's about making that data easier to access. So that's one of the projects that really excites me. And then the third one is the one that product people often, or at least product engineers often think about immediately, which is how can I take AI and insert it directly into a customer-facing product or service? So I I think you heard from the Shape folks earlier this week how they're doing things like that in fraud. DDoS is something that Mudith and I actually worked on together a few years ago, where we used AI, not large language models, but we used other methods like pattern recognition and clustering to identify good traffic from bad traffic. And that there, what we did is we put what that value propositions there, because it was automatic, it made it very easy to use. And because it was highly tailored, it made it very efficacious, very effective. And so in terms of inline DDoS mitigation, it was probably unparalleled. I don't know if anybody's even really done that today. So that's an example of a customer facing thing. And then there's going to be lots of things we'll be able to do. I can naturally talk about security things, but there are things that we could do outside of security, things like auto scaling, things in the APM being performance management, SLA, guaranteeing SLAs. That space has a lot of areas where we can do things. Another area, and this is about when I was making slides this morning, I ran out of time, is in policy creation. Another really exciting area, and one that is really appropriate for generative AI and large language models, is to create a policy, right? Again, if I think about those 3 E's, customers love, at least on Big IP, which is what the product I'm closest to, and also an NAP, right? If we think about security, we have a very powerful solution set, but it is difficult to use. People don't know all the features. If we can make it easier to use, if we can take intent, something or a higher level specification of this is what I want out of my policy, and map it into the specific policy directives, that would be an incredible capability that I think would really differentiate us from the rest of the market. So now I'll go into a quick bit of technology primers for non-techies. Now, here I do not mean to repeat the presentation that Saxon, I think, gave on Monday, talking about all this. I want to take a more pragmatic view of this is what, if I'm building solutions, what do I need to know? So for those of you in the audience that are highly technical, forgive me, I'm gonna take some shortcuts here, and I'm not going to necessarily, I'll probably cut some corners in the descriptions, but here I'm trying to say, here's a functional view of it, not a super technical one. So the first dimension to think about, if you're thinking about an AI solution, and I think product, here my audience is as much product managers as it is engineers, right? Is to say, well, when I think about the solution, what the problem I'm trying to solve, is this something that could be solved? If I think about the workflow that a human might do, is a human just applying a bunch of rules, and you'll see this in expert systems, like if I see this, then do that. If I see this and this, then I probably want to look over here. Is it sort of knowledge that is encoded in a bunch of rules? If so, there are rule-based systems in the framework of AI that we can look at as solutions for that. And the benefit of using those systems is, right, they'll automate those rules and can apply them to a huge set of data much more effectively and much more quickly than a human could. The second set of methods are statistical methods. These are things that can be typically used in one of 2 ways. One is to detect anomalies. So if your problem statement can be described as, I have a bunch of good traffic, or maybe a bunch of bad traffic in the case of DDoS, and I want to find the stuff that is different, that doesn't look like that we call that an anomaly. And some of the traditional AI methods are very good at detecting anomalies. Related to anomalies, statistically, are patterns, saying one way to think about one form of patterns is clustering. To say, I don't just have, if I relate it to a security domain, or maybe even a load balancing domain, I have patterns of how customers might go to my site. I look at patterns of where they might come from, what their browsing patterns are like, what the pattern of time of day of their access is like. And I put them together. I said, there's maybe a pattern of people who log into a time card site at around 9 o'clock every Monday morning. And there's a pattern of people who look for sales every right before every holiday. And so I've got these patterns. Identifying these patterns, looking for things that fitting things into patterns are things that that AI has historically been very good at. That's statistical AI. And then we get into neural nets, which are a little more inscrutable. So that's one of the downsides of them. But sometimes if you can't solve things statistically and rule-based, it's sort of the fallback solution. And it really works really well. So, you know, again, you give it inputs, you give it training. So neural nets require training. We'll talk about that in a minute. And it kind of gives you a smells like, you know, I've seen a bunch of pictures, a bunch of customer patterns, whatever they are. And this sort of smells like that over there. It may be, you can think about it sort of like I described clustering, but even more advanced. It doesn't have to be an isolated cluster. It just says it smells like. So that's the methods that are used. Then we have what are the outputs? What do you want to get out of this AI in the solution? Is it about just a classification? Yes, no, binary classification. Ham versus spam, DDoS versus good traffic. If so, that leans towards, you know, some of the methods that might be more statistical, correct? Or is this a general, what we call general classification? And, you know, cat versus dog versus horse. Is this, you know, what sort of app is this? Is this a, well, this is a really trivial example, but, you know, is this a Linux app, a Windows app? Is this a B2B app, a B2C app? You can do general classification. Now, those are very, very high level, but it's good at that. Those are both classifications. The app provided is a class. What has made generative AI so transformative and so different is now we have a way of producing outputs that make something. That's what the word generative in generative AI is about. It generates, it makes something. It makes text output. It makes an answer to a question you put out. It doesn't just classify something. And again, in the context of what we talked about, it generates a policy as an example of something. It generates code for let's say we use it for iRule creation. It generates code. We also have some legal issues that we have to work out about generating code as in software code, but the capability exists. So I'm providing the technology primer. There's a legal aspect of this, and I know Tom and his team are working very hard on providing that, and I want to give them a little plug to go reach out to them if you have some ideas. I think they've already reached out in the last couple of days. I'm not sure what's happened, but generative is what is really transformative. If you need to make something, it's really the only game in town. The third dimension I would think about if I'm thinking about, well, I want to use AI and is AI the right solution? What sort of AI should I use? Is what sort of training is required? Is it no training? In other words, it's built in. Those rule-based systems often don't require training. It's all built in. That's really, they have pros and cons. One is you don't need to do any training. Downside is it's not necessarily very adaptable if things change. But you know, some problems don't need a lot of training and they don't change that fast. So for those, that's great. And there's a set of AI techniques that are appropriate there. If you do need to do some training, you need to decide how much supervision is needed. There could be completely unsupervised learning where no feedback is required. That's less common, but I use this word, which is not necessarily in the technical vocabulary. It has different meanings, but I call it self-supervised. That is, there's feedback, but the feedback doesn't require human feedback. The DDoS example is an example of what I'll call self-supervised. There is training required, there's feedback, but the feedback in the case of the DDoS example was looking at the stress level of the system. So you had a built-in feedback mechanism. I can look and say, hey, is my server getting overly loaded? If so, I can tell there's some stress there. Another form of feedback is a technology you might have heard of called GANs, where the AI competes against itself or against an analogous, a partner AI to improve itself. This is really great when you have a well-defined set of success criteria, like what do I need to do? So a game like chess or like Go is really well suited for this. You know what all the legal moves are, and you know what success means. So the way that the world chess champion in Go got to be a computer is it played itself millions or billions of games of Go and got better and better and better. And the reason it was still feedback, but it was getting feedback from itself or another AI model. So again, the feedback is not from humans. And so that's a way to bootstrap and keep humans out of the loop. The reason I emphasize humans is if you need truly supervised feedback with, or supervised learning with human feedback, certainly sometimes that's what you have to do, but it requires human input or human feedback. So in the case of some of the traditional method, like neural nets and classifiers, you need humans to say, this is a dog, this is a cat, this is a horse. There's no way for the AI to figure that out on its own in those methods, in the way things were done. Another place where, another form of quote supervised is in the generative AI. It doesn't require human feedback, but it requires human input. In the sense of the corpus that is being used to create those answers is something that humans generated up front. So, right, if you use ChatGPT, it's been trained on the contents of the internet, circa whatever 2021 or 2022. If that project I mentioned that really excited me about using DevCentral and knowledge base articles, that requires human input. That requires those articles to have been written and the content have been created by humans. And so that's a form of, I'll call it supervision, perhaps there's a better word, but having had content created by humans as a prerequisite. Again, these are things to think about. Think about, how much do humans need to be involved? How does that affect the cost of the solution as seen by the customer? Or does content already exist? In which case, I can leverage that content by AI, or maybe the content doesn't exist, so that could be a barrier. Do I have the data I need? Those are things to think about as you think about the problem. So what I was going to do next, what I ran out of time this morning, was sort of now a little flow chart or how to think about the problem. So first, start with the problem statement. That was, where I start, where I think we should all start with the problem statement, and think about the problem. How much of the problem is ease of use? Is it efficacy? Is it efficiency? Most problems are a little bit of each, but it's still useful to kind of break it down to say, what am I really trying? What am I really trying to solve? Because it will help you determine what the right AI tool is. The second is how unique is the solution? How tailored does the solution need to be? Is it, hey, I needed to have this per application, maybe even more unique than that. It's every application, but if I'm tailoring it to how the application is deployed, that might mean I need to update every time there's a new CI/CD deployment. That's at the extreme tailoring end of the world. At the other end, you have, it doesn't really be tailored very much. It's global. Everybody will use this. The example I gave of animals, right? Cat versus dog versus horse. Odds are, definition of cat, dog, and horse aren't going to change a whole lot per application, per customer, per industry, per threat type. So again, you can have it. That's where we can say we can have a model. Maybe it needs to be trained, but it's pre-trained. All that's happened. The customer doesn't need to do any training. And then you have a bunch of things in between. Maybe it's per application. Maybe it's like not per application, but it's unique to the customer or the industry. Or maybe it's unique to the type of threat you're facing. Like I can tailor this model, but it's really going to be appropriately used to classify bots versus humans, but not so good about good versus bad traffic. Or maybe it's good versus bad traffic, but not about bots versus humans or something else. So think about that. The reason to think about that is it gives you insight again into what method to use. Do I need supervision? What form is that feedback going to take? A third dimension to think about is the workflow, how it's going to be used. So we've got a problem, we've got a solution. What is that workflow? is it about autonomy versus assistance? That's a good first order thing. If it's about assistance, that is about helping a human, then you're going to lean towards a set of models. Maybe it's classification, that more classification oriented and less generative, because the human might do the generation. Or maybe the assistance isn't the generation, the human creates the content, and such as when you're creating an article, maybe the human creates the core content and the assistance is making that more polished. Either way, it does that. Or maybe you find that one particular, or work the other way around, you find that one particular AI technology is better suited for the problem. And so now you say, okay, because of that, that is or is not a solution that works well with full autonomy. So you go, okay, I'm not going to make it autonomous. I'm going to design a workflow that is assisting the human, not being autonomous. Or you might choose autonomous. If you think autonomous, and there might be reasons for that. In my space, in the security space, autonomous is often chosen because of, mainly because of the speed of reaction. In other words, if a response is needed in seconds, a human can't respond that fast, so you have to give the system autonomy. That's fine. If you think about autonomous, why is it autonomous? And then what are the guardrails you're going to place on the autonomy? Are you going to let it do anything you want, or do they need to be guardrails? Think about what do the guardrails need to be. I think I kind of alluded about this next question. Is it about classification versus creation when I was talking about the previous thing? Think about the nature of the problem. What is, again, when I think about the requirements, are the requirements about generation, about classification, about binary? So those are the considerations. What I want to do, what I ran out of time on, is to then link this together and by saying, okay, let's take, I was going to take a sample problem or build a little table that says, let's take the sorts of problems we have, map them to the AI technologies and go through that. Because since I don't have that, I thought, and this is where I was going to phone a friend and do the audience participation part. And I was going to take some examples, maybe from Greenhouse, others maybe the audience might have, and we'll walk through them to try to make this a little less abstract, a little bit more concrete. So that was the prepared stuff I had. Before I go into that, are there any questions, Mithila Feta, that were pending that we should do before we do some examples?
Yeah, Ken, we have a few questions. So first question is, how can we use AI to curate API reference documentation into categories discoverable to customers that want to solve their specific problem?
So let me make sure I got that. So API, the questions around API discovery and can you repeat what does the person want to do with API discovery?
So I'll repeat the question. So how can we use AI to curate API reference documentation into categories discoverable to customers that want to solve their specific problem?
Okay, so let's see. I'm thinking on the fly here. So I want to do API classification and documentation. So first of all, I mean, so there's some projects that are underway that will, first of all, create a more formal spec out of the APIs we have. So one thing I'd say is look at the tools that can generate open API Swagger specs out of existing RESTful, at least RESTful APIs. Then you have potentially you could use AI for classification as needed. Now, okay, well, first let me answer the question, then I'll get on the soapbox. So I would say that this is probably, if I look at the AI techniques, this is a classification problem, not a generation problem, kind of walking through the framework I just gave. And say, okay, well, what are the characteristics of these APIs that I might look at? I might look at the paths that the APIs have. I might look and say, what sort of, are they protected or unprotected? If they're unprotected, they're hopefully meant to be for the world. If they're protected, they're probably more meant for proprietary users. I would look at the inputs, the nature of the inputs, and I'd see, are there patterns there? Without actually looking at the APIs, I can't be more specific than that. Now, my soapbox on this is going the other way around, is that when AI shouldn't necessarily be used as a crutch to say, well, AI is never is unlikely to be as good as a human at some of these things. In other words, if I want to take an API for my product or services, and I want to make it more, I want to make it easier to use, I want that there needs to be some documentation, some seed to start with, like, hey, these are developer APIs, these are public facing APIs, these are protected versus, in other words, require administration privileges. These are application specific APIs versus platform APIs. That sort of information, while you could try to use an AI system to classify that, that's better done from a human. So my little soapbox here is, while I could use AI for that, that's one of those things where the right place, if I'm talking to an FI person, is to say, well, why aren't these, can we document these AIs ourselves? Why aren't they documented? We're writing them ourselves. We should be documenting them. If not, we use an AI. What can I get from you as the developer of the API at F5, and that I can use to seed the AI, and the AI can then help with the generation. That would be an assistance workflow, not an autonomous workflow. I don't know if I answered the gist of that question. If the person who asked that, feel free to ask a follow-up question in the chat while I go on to the next one.
Yeah, so Ken, the question was from Mark Rovera. Thank you, Mark. And I think that you gave a lot of context, but just to clarify, the question was, I think, if I understand it correctly, that API reference documentation exists already, and perhaps it takes a lot of time to find the correct portions of that documentation to figure out how to use the correct APIs in order to solve a specific problem. And so the question is, can AI help to curate the existing API reference documentation into categories? And then the developer who's using this API, doesn't have to spend so much time figuring out exactly what API to use for building their application.
I think that's fair. I think, again, I go back to this should ideally, that workflow is ideally, in my mind, an assistance one, not an autonomous one. Like, here's a bunch of APIs, go figure it out. It's, I've given you information as a developer of the APIs. Can you assist me by making that workflow more user-friendly? Or another great use case for this is to, if we have some code examples that are part of the documentation, then we could use generative AI, modulo any legal concerns. I want to make sure that I don't run afoul of Tom and company, but can we use AI to then provide examples, saying, oh, you want to write this code in Rust? Here, let me show you a Rust code snippet for that AI, for that exam, how to use that. That's not the classification problem, that's the generative problem.
I think you now answered the question. We can go to the next one. Thank you.
So Ken, is it correct to understand that in the context of machine learning, the use of a corpus typically involves supervised learning, while a feedback loop enables self-supervised learning later on?
Okay, so yeah, the generative AI, and the word supervised, I realized as I was writing that up, that I encompass two different, yes is a short answer. The longer answer is I incorporate two different things in that word, supervised, both the stuff that's used for pre-existing, like the corpus, which, yes, generative AI needs that supervised or pre-existing corpus. And then the other form, and then there's the other form of classification, which is actually, there's another nuance here I'm trying to figure out how to work in properly. There is training to build a model, which is very much a neural net sort of way of describing the world. I'm going to train the model and I'm just going to execute and run that model. Evaluate is a word that's being used. And there, yeah, I do. I need that pre-existing classified part of the world. There's another form of that feedback, which is, I'll call it continuous learning, which is less about neural nets and more about some of those other techniques like clustering and pattern matching, that some of those older methods where they're always learning, they're always improving. In other words, if I take that, I like clustering because it's nice and visual and it's easy to imagine. You can just imagine like a 2D or 3D graph with these clusters in it and that you can easily pick out visually. So you can imagine that if you have that mental model, you get, as you're running, there's not a distinction between training and evaluation. Just as you're running you get another data point, it adds to a cluster. and you're always continuously learning. And that feedback with self-supervised, to kind of put more color on the question, is for clustering other things, is continuous and works better with self-supervised.
Great, thanks, Ken. Next question, would like to hear your thoughts on currently unsolved or unexplored areas of ML and AI. Any big open problems you are thinking about?
Oh my. I certainly would not presume to be anywhere near an AI ML expert who's like pushing the frontiers of what goes on. So things that I think about, which I would not in any means qualify as cutting edge technically, but I think about guardrails, and I think about ease of use and explainability. Those are things that I think about. So if I've got an AI solution, I worry about how am I going to make the customer trust it and use it. And I come back to, if I can give some explanation as to why, that will help the customer trust the answer. If I just say it's a black box, it's an oracle, you don't need to look behind the curtain, that doesn't help build trust with most customers. Second, I think about governance concern. I might, in many industries, there are, when we use AI, there are legal requirements. A simple example is insurance. In insurance, there are things, there are criteria that you can discriminate on, such as driving record, and there are things you cannot discriminate on, such as race. How do you ensure that an AI model isn't doing that or complies, or if it is doing that, how do you make it not do that to comply? So that's a second thing I think about, and that kind of goes to the guardrails. How do I put guardrails on what to do? If I want autonomy, I want to take a human out of part of, there's a push to take the human out of the loop because it makes things cheaper, it makes things easier, but how do you control it? Are there any guardrails? Think about that. Think about, and how do I up level? I talk about policy creation and creating policy from intent. Well, what does intent really look like? How do I specify what I want the system to do? And how do I come up with a framework, a language to describe intent? Those are things that I think about, don't have answers to, but things that I think are unsolved problems that relate to FI.
Okay, so we have a question around the hammer analogy that you used earlier. So the who here is customers wanting software sooner, or testers who are overworked. The what, software testing cycles, and the why, software testing is notoriously long, complex, and inefficient. Is this a hammer?
I'm going to read the question.
Yeah, go ahead.
Let's see here, hammer. Okay. Yeah, testers are work, so I have to rely. It's long come. Okay, so hammer. I think that the statement is true. Customers, software engineers are always having to, build things quickly, test things. I always want to test things more. I'm going to kind of answer a testing. Well, okay, test cycles are long and inefficient. Now, is that hammer? I don't know. I'll start with, is that something AI can help? AI can have a role to play there. I'll speak personally. This is a project I did, and first of all, I did this project partly because it's personal to me, but also more importantly, it talks about this is not a new problem. AI has been a recent flash, but people have been working on these problems for years. A tool I developed, I want to say the mid-90s, it tells you how old I am and how far back this goes, and I was not new when I did this, is to write a test tool that looked at places of code that were problematic. Where in the code did I find the most bugs, and which tests found the most bugs? And what we did, it was that particular project was which test found the most bugs. And what we did is we fuzz test around that. So I wrote a tool that took an automated test. So first of all, you need automated tests to do this, but once you have automated tests, it said, oh, this automated test found a lot of bugs. And it would fuzz and build new automatic AI generated automated tests that were that base test, but fuzzed a little bit. It would change some parameters and then run those automatically and see if those tests found bugs. And it almost uses a genetic algorithm to say, hey, the tests that find the most bugs, we're going to make more copies of autonomously. They're going to run, and those that find the most bugs, we're going to run. And that was just one way of applying AI to testing, to improve testing. And that's just one way. And I'd be happy to have a longer conversation about other ways. That's a topic that's important to me. So AI has a role to play. Now, it's not, now the hammer part of this analogy is it's not the only tool, right? There are other things like, and they work hand in hand, code coverage metrics, buzzing tools, all those things they work with AI. So AI is a tool, but only a tool in the toolkit. And in the interest of time, I realize I take about 5 minutes per answer, so I'll stop. Feel free to reach out to me, Charles, and I can give you longer answers.
Thanks. So I'm gonna ask this question. Many people may have high hopes for AI for some use cases, but in reality, the results of using AI may not be as good as expected. In these cases, what is your advice?
Like anything else, why? Start with why. It all starts with why. Well, why is it not as good as expected? And sometimes that's hard, right? If you're using, going back to that, my concern about using an inscrutable black box. It's an inscrutable black box. It's kind of hard. You can still try a few other things. And again, there's a deeper technical discussion here. You can try to vary model parameters, model inputs. You can try different models, but try to get insights as to why. And those insights will probably lead you to where to go. They might say, AI is not good because it needs to be trained too often. There's too much variation. It needs too much tailoring. I pre-trained it on something that looks too different. It may be that we don't understand the problem well enough. I might be using a rules-based system, but the rules are not the right rules, or I forgot them, in which case I might tune the rules. I will say this, that one thing I always keep in the back of my mind when I'm looking at how can I make this better, why isn't this working, is I might say, if I were a human, if this AI is assisting, automating what a human might do. If I were a human, could I solve this problem? If I can't solve as a human, don't expect the AI to necessarily come up with a magic solution. If I can, but the AI isn't, I'll look at what's the difference. What am I doing that the AI can't? And then say, can I maybe train an AI to do that? That's general advice. Again, specific use cases we can talk about.
Next question is, how can one determine whether an objective can be met through prompts against the model? Tuning a model by additionally training it against our private data set, or creating a new model? Okay, so I guess this is in the context of LLMs, whether an objective, I'm going to parse objective as a sufficiently high quality answer, generated answer. And then the question is now, is prompt engineering the right thing? Is it, putting embeddings in there? I'm putting some technical terms in there, or do I just need to have a brand new LLM? I think that I might turn the problem, I'm thinking on the fly here, but I might turn that problem around a little bit and say, with each of those approaches, how good can I get? So those 3 levels, prompt engineering versus putting in maybe a pre-model and embeddings versus doing a brand new LLM, those have distinct levels of, or distinct plateaus of complexity, quantum levels of complexity. So I might say, how good can I do with prompt engineering? And this is a new field, so we're still ourselves learning how much we can do with prompt engineering. And if you've been, so James, if you've been studying this, right, you can say, hey, the people have some of the best practices that have been discovered so far. So try those and see if you can get better, but see how well you can do. Then say, if I do something with some pre-processing embeddings, how well can I do? What are the right embeddings to use? Play with the different models and see how well I can do. The latest, I think, Ada model from ChatGPT is supposed to do a lot better with embedding. And I don't even know if we can create our own model. That just may be computationally unviable for us. We can have that conversation. And then I'd go back to the problem. Say, what level of efficacy, the word here, objective, can be met. Therein lies the key. What is the level needed to solve this problem? And if it's full autonomy, it might be a higher bar than if it's assistance. So I do that. I personally,
would do prompt engineering for as much as I could, realizing it's not going to go far enough. Then say I'm going to do embeddings and slightly fancier things for places where there's high value, such as say that knowledge base article mining I talked about. And I'd be really reticent about building a new model from scratch, at least for languages. Now, for other things, I would be willing to do that. That's, again, the short.
So a question here, I've seen LLMs described as plagiarism and permutation engines. Can this guide the kind of problems it is appropriate for?
No, absolutely. I thought you were going to be worried. Peter, I thought you were going to be worried about, is plagiarism and permutation going to be a problem? Yeah, probably Tom can speak to that. Yes, absolutely, it can guide. It's if, one way to think about, is this problem good for LLM, is if I had access to all of that information out there and I could plagiarize and permute this, and I just needed the time to do it, but I could solve my problem that way, that means that it's probably a good thing to use an LLM for. You have to be careful though, in that is there other domain expertise that's required that the LM may not have? That might be discount LM, but it would be at least a good place to start thinking about when to use a large language model. Conversely, it's also a reason when to think about when not to use a large language model. If plagiarism and permutation are inappropriate for compliance, legal, moral, whatever reasons, then you probably say, well, I probably don't want to use an LM because I'm going to run into those issues if I do.
Okay, and then we have a question here. I am an absolute beginner with AI. I want to spend a good amount of time to become an AI expert. I started already. What do you recommend and how to go way forward?
This is very general advice, right? I mean, I think that it depends on where you want to go with this, right? I mean, if your goal is more, again, I'll say the pragmatic, I just want to build a solution, I just play with a few things. I'd play with, and I think the Greenhouse team, resources within F5 are going to be making models available in the next, we can talk to, but in the next weeks to months, that you can play with. You can play for anything, large language models. You can play, we'll try to get some Jupyter notebooks up and running. Just play, see what the tools are capable of doing, get a sense of what they're good at, what they're not good at. Read, right? I mean, use ChatGPT to help train you if you want, read some things. This is all very generic standard advice, but playing with it is important. And that's how I think that's where you can say, okay, you'll get a sense of what tools are out there, what tools are well suited to what problems, what the obstacles are going to be, and everything pragmatic, like integrations, right? If I actually want to build something, what languages can I integrate with? What environments do I work with? I was playing with GCP the other day, trying to get some of the large language models up, OpenGPT up and running. Turned out, at least a couple of weeks ago, the VMs, the NVIDIA accelerated VMs on GCP weren't well suited for that. I think just a couple of days ago, GCP did something about that. Those are practical considerations you'll learn by doing. Now, if you want to be an academic expert, there's a whole set of academic papers that you can go look at and read, but that's a different sort of outcome you're going for.
Can you recommend a good open source LLM?
I have no exhaustive stuff. I've been playing with OpenGPT, with I can't remember the name of the vector database. This is where being in Maine for 2 weeks and playing with chainsaws has muddled my brain. I've forgotten the names of them, but there's some good open source vector databases. GPT for all is a good thing to run on just your local machine. If you happen to be, Saxon happened to have a fancy GPU on his home system, so he loaded some of the Llama models on his home system to play with. So those are some. I think the Greenhouse team is putting together a AI page with many of those things, and we would probably send a link out afterwards as well. Yeah, and I haven't talked about some of the Hugging Face has models, and there's image generation, there's all sorts of things. Yes, absolutely. Thank you.
What hardware specific innovations in line with machine learning have you observed? Any recent advancements that excite you?
Jordan knows me. Jordan knows I worked hardware for a long time. Well, I mean, of course, right, the NVIDIA, the latest set of neural nets, the latest set of technologies, which is based on convolution, what technology known as convolutional neural nets. Basically, they're fast floating point multiply accumulates. And the fact that NVIDIA has put them into, NVIDIA's made them popular. The fact that, and here's someplace where Windows is trailing Mac. The latest M series chips on the Mac have that hardware on them is really exciting. So I think there's some really good stuff there. What I think is, and I've talked to hardware vendors about this. Some stuff that I think is lacking is stuff that's not about neural nets. And there are a bunch of reasons which I could have a longer conversation, having worked at Intel for 10 years, about why the hardware companies, ASIC companies, aren't doing those. But there's some other lower hanging fruit that I think could help AI. They're just not as sexy and glamorous. If you want some keywords to look up, you could look up things like grammar parse, hardware accelerated grammar parse, and window addressable memories. Those are some things that I think are things that we could be building on the hardware front, in the hardware world, that would also really help AI. Wow, and we're at 10. I didn't even have to pick on Move It. You're off the hook.
Well, if people want to stay longer, and I certainly can, perhaps you should pick on me and we should go through one project. I think it'll be a very good exercise.
Well, sure, I'm happy to do that. I can stick around.
All right, so what I'm gonna do is, and even if it's just you and I left, I would love to see how you would work this project. So what I'm gonna do is quickly share my screen.
Okay, I will stop sharing.
Yeah. And here you see the page that I have been pasting, and I invite the audience to actually submit their own idea that uses AI in general and generative AI being one AI mechanism. When you submit your idea, you will be able to form teams, and this entire month is for really clarifying your idea. And at the end of the submission period, which will run about a month long, we're requesting people to submit 2 to 3 minute video pitches explaining their idea. Please note, no POC is needed here. In fact, until the legal and security concerns are worked out, and the sandboxes that Ken was mentioning, for which we're doing TMAs and TPSAs, so threat model assessments and third-party security assessments, until those sandboxes are ready, it's actually better not to do POCs and just focus on clarifying the idea. So if you submit your idea, we will begin to help you to clarify your idea further. And Ken, I'm just going to pick one of the ideas that was submitted by an F5er. So I'm just going to look at this one, the support copilot. I see 2 ideas that are very similar. Perhaps these 2 teams should unite. This is another value of submitting your idea. You find other people who are thinking in the same way, and you can join forces. So support copilot and support GPT. So let's look at this one, Ken. So view details. And loading. I am coming in from India, so things are a little bit slow. Okay, so the idea is to develop a generative AI system that can analyze QKView diagnostic files from big IP devices and associated service requests to quickly and accurately determine the root cause of an issue. We propose the development of a generative AI system that can quickly analyze diagnostic files and associated service requests to identify the root cause. This AI system will leverage machine learning algorithms and natural language processing techniques to compare new diagnostic files and cases with historical data, identify patterns, and suggest potential solutions. And I think the benefit here is faster resolution of issues. So I think, can you get the gist of the proposition here? how would you go about considering how we should use AI in general and generative AI in particular for this specific idea?
Okay, so without sounding too much like a broken recording, I would start with a problem as opposed to start with the solution of how will I use generative AI. That presupposes that generative AI is a solution. I would start off by saying, what is the problem? And I think it's a very valid problem to solve. It's like I would like to be able to quickly identify the root cause of issues by examining a configuration. That's what we get from the quick view, and known and service tickets maybe that are associated. So that's where I'd start. And I'd say, okay, great. So I might also at least start off with a version of that workflow. Like, what does that workflow look like? That workflow is going to start by looking, I need to submit a config, PKV is that, and I need to be able to pull out the service tickets that are associated with that customer. That's the basic thing. And I might first think, well, how much data is that? And can I do something? And how might I do something? One of the things, if I think about generative AI, is that generative AI tends to need a lot of training data, right? It needs a large corpus. So I would start off by saying, gee, if all I have is like a config file and 3 service tickets, that's not a lot to deal with. So I probably need to say, okay, well, can I get data from other service tickets from other customers, from other config of other customers? That's a legal question. So I'd start by saying, if I can get a bigger corpus, which, that would help, I would say, hey, maybe I want to use generative AI or some sort of large language model for that. In which case my problem statement now changes to, I have many configs and many service tickets. And I now want to do something that can correlate service tickets with configs. Now, how do I know what that correlation is? Well, it would really help if I had some trained data. Yeah, I was getting to that, Bob. Thank you. Yep. Yes, I will get. Bob made a very good comment in the chat, and I was going to work my way to it. So I'd say, okay, well, great. I probably need to do, if I'm going to do a good job at it, I probably need some supervision. I'm going to make an assumption here, and I'd probably be clear about what I'm assuming, because I have to go back and check my assumptions later. But I'm going to assume that in order to do a good job at that, it probably needs some feedback, some way of saying, in the past, when I've resolved these service tickets, it's related to this part of the config. Because if I have that information, I can now feed that into the large language model and say, hey, when you see these sort of service tickets, and I'm being deliberately vague here because that's what LLMs are good at, being kind of vague, these sorts of service tickets, I will now see, I see these sort of policy changes, and I can do that correlation. And then now I get into the details of the LLM. I'm gonna pause. I'm not gonna go deeper down that node of thought, that leaf of thought, but I might start off with that. I might say, it might be though, on the other hand, I can't get this large corpus, in which case I might go, what are the other things? Again, don't jump to, I want to use generative AI. Jump to, I want to solve the problem. And as Bob talked about, maybe issues with this that I've seen before, a human does this because by having a set of rules that maybe that a human expert, maybe within the iHealth team, maybe within the support team has, and says, hey, I can build a rule-based system, not an LLM that does this, that can say, hey, or if I see this sort of issue, this is how my car mechanic works. If you see this light or this sort of symptom, it's probably one of these 4 things. See this sort of service ticket, it's one of these 5 things. Now, maybe that's an expert system. Maybe that's something that has nothing to do with the specific problem, but I can build a subsystem using classification, maybe I'll use a large language model that says, when you see these sort of issues, here are the likely root causes in the policy. And then I can build something else that says, now with these likely root causes, I can go back at the policy and say, what are these, do any of these policies, now going back to the car analogy, it's like, I think it's one of these, you have this symptom, the car idles rough. It's one of these 4 causes. Now, how do I do that? If it's cause A, here's my test. Cause B, here's my diagnostic test. Cause C, and so on. So I now take I apply that same approach, saying, okay, I built this subsystem that says it's probably one of these things in the policy, and now I go back and I say, I can again build a large language model. I can build a heuristic. Maybe here some sort of language model is appropriate. Maybe not ChatGPT, but a specialized language model that understands policy and says, from this policy, it understands I'm getting into technical details, but maybe a language model is the right tool. But I'm going to direct the language model by say, look for this sort of problem in the thing, like a particular sort of signature that is not enabled, or a particular combination of configuration settings. Again, specifics depend on the particular problem. And I do that. And so that's how I might approach it. I might even err the first time I go through this. This is an iterative process. So the first iteration, I do this with more manual intervention, like with rules and with what, looking for people, looking for specific things. And then my next iteration is say, how do I automate this? How do I make it a little more easy? Because I want a system that every time I find a new class of bug that I don't have to, okay, right now what will happen? How do I keep up with it? Another expert writes a new rule. That's using a human. Maybe I can automate that. And now the second iteration is how do I automate some more stuff in there using AI or some other system? And again, I don't jump to generative AI. I jump to, how do I automate AI? I mean, if I step back, AI is really about automation. How do I automate this? Are there AI techniques I can use to automate this? Is a large language model the right thing? And as several people in the chat have noted, iHealth does do something like this today using a rule-based system. Now, my understanding, and somebody on the chat can correct me if I'm wrong, is that it is not. It's more difficult to maintain because it's hard to keep it because it relies on these human experts to write rules, and that does take time, and sometimes there isn't time to do that. So if I could make that either easier for those expert humans to encode what they know, or make it more automatic and just have the human experts review what's being done, that would be better.
Cool. Thank you, Ken. I think that was a very good description of what we might do. I see there's still 127 people here, and there are 27 other ideas we could go through, but we should probably call it a night in India.
Yeah, what time is it for you? It's like
10:41 p.m. Yeah, 10:41, and a day in other parts of the world. Safida, back to you.
I will say that well, I'll speak for myself. I think Mudit would say the same thing, that, this is something it matters to me. It matters to the company. Feel free to reach out, ping me directly. I'm happy to have conversations with people about this because this is important to where we go as a company.
Yes, and please, we firmly believe that all of you have good ideas about how to use AI and generative AI to improve, your day-to-day workflows, improve our products. And if Ken did an excellent job of specifying in very, very simple terms all the things that we could use AI for. So it's critical that all of us put on our thinking caps and come up with ideas, and please submit them in the Idea Fest form. It's going to create conversation and form, allow us to come together, cooperate and collaborate in clarifying the ideas so that they become actionable. And we got to do it in order to keep pace with the rest of the industry. So thank you for listening, and thank you for your attention. Go ahead, Fida.
Absolutely, and take a look on the page to see what teams have been formed too. If there's an idea that catches your eye and you would like to add on to the overall description and problem statement there. With that said, there's a few more questions, but we can answer them offline. I'll make sure to connect Ken with those fibers. And thanks for joining today. Our next session will be on July 5th Pacific time with Rupert Young, where he will walk us through an application of data science at Applied. So be on the lookout for that invite. It's really exciting content there. Thanks so much. And we'll talk to you soon. Take care.
Thank you.
Thank you. Bye-bye.
Bye-bye.